Hello. So I have a couple of problems right here that you can use as warm up to kind of help you to get your mind going on these things right here, dealing with distance and stuff like that. So it says use Pythagorean theorem to find the missing links of the right triangle, round to the nearest tenth. And so those are just some warm up problems that I kind of put out here. But let's move on to what we're dealing with today. So today we're going to be talking about the distance formula. And so when we're dealing with the distance formula basically says that I'm trying to find what is the length between 2 points, whether those points are one-dimensional, whether those points are two-dimensional, still dealing with the distance formula. So if you notice right here, we're basically saying given this point and that point, what would be the distance between them, okay? Or given this point and that point, what would be the distance between them, okay? So notice, if I give you these 2 points right here, what would be the distance between those 2 points? Okay, that's something that we're trying to figure out. So when we're talking about the distance formula says that given one point, represented by x1, y1, and a second point, represented by x2, y2, I can use this formula to help me find what is the distance between those 2 points. Okay. Now, one thing that you definitely need to make sure that you remember in the distance formula, all right, and you need to write this down in your notes. Distance is always positive. It is always positive, no matter what, okay? So when you go through this process right here, plugging in what you have, simplifying it, all of that, the last thing you should remember, or the first thing you should remember, is that if your answer comes out to be negative under this square root, you didn't do something right. The reason that it should never come out to be negative is because no matter what happens in here, when I square it, it's going to be a positive answer. No matter what happens in here, when I square it, it's going to come out to be a positive answer. And that's what you have to keep in mind, okay? So let's move on. So here's some steps to setting up or solving the distance formula. First of all, write the distance formula, all right? If you can't remember, if you know that it's something that you need help with, then write it down. The next thing you want to do is, if the coordinates are not already given to you, label them. Then you want to substitute what your coordinates are. And when we're talking about substituting, we're talking about labeling or substituting in your x1 and your y1 and your x2 and your y2. That's what we're talking about when we say substituting. Then you want to simplify the parentheses, evaluate the powers, add the two integer answers that you get, and then simplify the radical or round. Just depends on what the question is asking. So let's look at number one. Number one says use the distance formula to find the distance between these two. Okay. So the first thing that I ask students to do, besides just writing down the distance formula, remember the distance formula, we'll write it down, is x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. So when I label this, this is my x1, this is my y1, this is my x2, and this is my y2. So if I were to take that and plug it into the formula, all right, the distance formula, notice that's what I would plug in. Okay, so remember, x2 goes here, x1 goes there, and it's a minus between them. y2 goes here, y1 goes there, and it's a minus between them. We end up getting negative 3 squared in parentheses squared plus negative 1 in parentheses squared. And this is where students tend to make mistakes, because when they try and use the calculator, if you do not put the negative 3 in parentheses and square it, your answer will come out to be a negative number. So it is important to put the parentheses around your number and then square it. Same thing right here. Put the parentheses around your number and then square it. Even if it's a positive number, put a parenthesis around it. We end up getting the 9 plus 1 under the square root, which gives us the square root of 10. Square root of 10 is already simplified, but if I wanted to round that answer, I would round it, and I would get 3.16. Okay? Let's look at another example. Number 2. Use the distance formula to find the distance between the points 10, 5 and 40, 45. Right? I'll give you a few minutes to work on that problem, so pause the video so you can work on that problem. So what I would do is I would label x1, y1, x2, y2, and I take those and plug them directly into the formula. We get a 40 minus 10 in parentheses squared, and a 45 minus 5 in parentheses squared. Simplify it. Simplify the exponents. Add. And then we simplify the radical if possible, and we get d equals 50. So if you notice the first two problems, we were actually given the coordinates. We were given the x1, the first coordinate and the second coordinate. But what if we're not given the coordinates? What if we have to find them? In this case. So I give you the problem. I say find the distance between the points, round to the nearest 10th. So if you notice right here, these points, we see the points, but we don't see the coordinates. So it's important, let's do a refresher. Remember, when you're trying to find the coordinates of a point, remember the first thing that you should always do is start at the origin. Start at the origin. Right? The second movement should be, you should move either left or right, depending on where you are. And then the third movement, you should move up or down. So let's try that with these. So if I look at it with this, that means that I'll start at the origin. I'll move to the right 1 unit. That represents my x coordinate, so I'll put that right there. It represents my x. And moving up or down represents my y. Well, since I started at the origin, I moved to the right. That means that my x coordinate is 1, positive 1. And since I do not move up or down from the axis, that means that my y coordinate is 0. Well, what about this second point right here? Well, second point, starting at the origin, I had to move to the right 4 spaces, which means that my x coordinate is positive 4. And then I had to move up 2 spaces, which means that my y coordinate is a positive 2. So notice I now have both of my points, okay? So now what I can do, sorry, that's the bell at school, sorry. So now what I can do is I can label them. This is my x1, my y1, this is my x2 and my y2. And now I can plug them into the equation. So when I plug them in, notice x2, which is 4, minus x1, which is 1, and y2, which is 2, minus y1, which is 0. Simplify. And then if I ask you to round, you would get 3.6. And that's rounded to the nearest 10th. Work on this problem right here and see if you can come out with the correct answer. So pause the video for a few minutes to see if you can get it. So remember, we said the steps were to first start at the origin. Second, we're going to move left or right. Third, we're going to move up or down. Right? So starting at the origin, I had to move to the left 1, 2, 3 spaces, so that means that my x coordinate would be a -3. And since I did not move up or down, that means my y coordinate is 0. Well, for this one right here, it is on the y-axis, so that means that my x coordinate is 0 because I didn't have to move left or right. But I had to move down 4 spaces, so that means that my y coordinate is -4. So now that I've labeled my 2 points, now I can label the coordinates. x1, y1, x2, y2. I have my equation, distance formula. I plug in what I have. Remember, if we go back, this gives us x2. Okay, oh, excuse me. I'm glad this came up. So, what we can actually say right here, and what I want people to understand is this. It does not matter which point is your first point and which point is your second point. Okay? Does not matter. Notice that in this illustration, my second point is right here. Right? So this is point number 2, and this is point number 1. Okay? So if I go through and let's erase what we have. And so now let's label this as, once again, this would be -3, 0. This would be 0, -4. This is my x1, y1. This is my x2, y2. And so when I look at it, once again, this is x2, this is x1, this is y2, this is y1. And notice what we have. We get a 9 plus 16, which gives us the square root of 25. And since I can simplify that radical, I end up getting 5 as my answer. So that's dealing with the distance formula. Okay. Well, what if we want to find the midpoint of between two things? So if I want to find the midpoint between two things, well, the midpoint says that if I have 2 objects or 2 points, I want to know what is the halfway. If you and a friend want to meet up and you don't want to go all the way to your friend's house and they don't want to come all the way to your home, then guess what? 9 times out of 10, you're going to say, well, hey, meet me halfway. And that's what this right here is saying. So, the midpoint formula says that the midpoint of a line segment is the point on the segment that is equidistant from its endpoints. Right? So basically what we're saying is that, so let's go back. If it's equidistant, that means that if this represents my middle, let's see if this works. Well, the person to the right is 1, 2, 3 units away. The person to the left is 1, 2, 3 units away. So it does work. Okay. Well, when we look right here, a lot of students would probably choose choose 0 as the midpoint, but really it is actually 1. Because let's look at it. 1, 2, 3, 4, 5, 6, 7 units away. 1, 2, 3, 4, 5, 6, 7 units away. So this represents my midpoint. Right? Now, the formula for midpoint, right, is x sub 1 plus x sub 2 divided by 2 and y sub 1 plus y sub 2 divided by 2. Now remember, it doesn't matter which order you put those in, as long as when you take the sum, you divide it by 2. Same thing with the y values. Take the sum and divide it by 2. But the key is to make sure that you label what you're given. Let's look at an example. It says find the midpoint of the line segment connecting the 2 points, and it gives it to us right here. So, remember, let's label x1, y1, x2, y2. Since I have an x1 and a y1 and an x2 and a y2, I can actually plug them into the midpoint formula. That gives me a -2, excuse me, and once again, they went through and we labeled them. So yeah, this is right. This is x1, this is x2, y1, y2. And then when we go through and simplify, we get 2 over 2, comma 5 over 2. Please make sure you remember, always simplify fractions. And so when we simplify the fractions, we end up getting a 1 for here. But then some students may say, well, how did you end up getting a 2.5, Mr. Collier? Well, you got a 2.5 because 5 divided by 2 as a decimal is 2.5. See if you can solve this second one. Pause the video and solve it. So, when we look at this, once again, x1, y1, x2, y2. I plug it into the midpoint formula. Right, I get 200 plus 25 divided by 2 and 75 plus 175 divided by 2. Now, the one mistake that a lot of students make is they only want to divide one of these by 2. But remember, you take the sum of your x coordinates and then divide by 2. And so you end up with 225 divided by 2 and 250 divided by 2. And when you simplify those, you get 112.5 and 125. When we look at this example, it says find the midpoint of the line segment. So now we're taking what we just learned and we're applying it a different way. Some students will look at this and say, well, Mr. Collier, that just seems like, how do we do this? Well, you do it the exact same way, okay? An example would be, I'll start you out. So if I wanted to know the halfway point between point T and point S, well, let's look at it. Point T is 2, 3. Point S is 7, 1. So that means I can label x1, y1, x2, y2. Well, that means that I've got a 2 plus 7 divided by 2 and a 3 plus 1 divided by 2. That gives me a 9 divided by 2 and a 4 divided by 2, which gives me a 4.5, comma 2. That is my point. That's my midpoint of this segment. So that means that I will actually come up here, start at the origin, count to the right, 1, 2, 3, 4.5. So this is 4.5 right here. And then I will count up 1, 2, and I would see that is my midpoint. And we'll call that midpoint M. Well, what about the midpoint between S and R? Well, S is 7, 1. R is 4, 2, -2. So when I actually go through, and I want to make sure we see that right here, okay, we label x1, y1, we label x2, y2. That means that we have 7 plus 4 divided by 2 and 1 plus -2 divided by 2, which will give us an 11 over 2 and a -1 over 2, which, when we convert it to a decimal, gives us 5.5, comma, -0.5. So I will start at the origin, count to the right, 1, 2, 3, 4, 5 spaces, all right? And then I will count down. Let me make sure I got that. And then I will actually count down, and let me make sure I actually go through this correctly. So this is, yes, right? And so this actually will come right here, right? Should be right here. So this actually would be up a little bit more. My graph is not drawing the scale, Okay. So once again, we start here. Excuse me, I'm sorry. It is drawing a scale. I didn't count correctly. Starting here, 1, 2, 3, 4, 5 and a half, and then I will go down a half. So actually I was correct, right? I was correct. And so we will call that midpoint P. See if you can find the midpoint between T and R. Pause the video to see if you can find the midpoint between T and R. So T is 2, 3. R is 4, -2. X1, Y1. X2, Y2. That gives me a 2 plus 4 divided by 2. That gives me a 3 plus -2 divided by 2. That gives me a 6 divided by 2 and a 1 divided by 2, which equals 3, 0.5. So once again, I start at the origin. I will count to the right, 1, 2, 3 units, count up half of a unit, and I see that is my point, and we will call that midpoint A. So let's put it all together. Okay. So when we put it all together, it says, on a road trip, you hike 3 miles north and 2 miles west. Starting at the same point, your friend hikes 4 miles east and 1 mile south. How far apart are you? If you want to meet for lunch, where could you meet so each person goes the same distance? Okay. So if we look at what we have, let's look at it. It says, you hike 3 miles north and 2 miles west. Okay. So you hike, starting from here, you hike 3 miles north, which is up, and west is going to the left, and so this is you. Your friend hikes 4 miles east and 1 mile south. Okay. So please make sure you remember that if you're going north, north means that you're going up, which means that it's positive. South means you're going down, which means that it is negative. East means you're going to the right, which means that it is positive. And west means you're going to the left, which means that it is negative. So if I look at this, the coordinates for this point are a -2, 3. Okay, so it's a -2, 3. Because remember, starting at the origin, even though I know this up here is worded a different way, we all, on the coordinate plane, we always start at the origin. So that means that we went to the left 2 units and we went up 3, and that's why we ended up with -2, 3. Right here, we went to the right 4 and down 1, so that means we have +4, -1. Okay. So when I label x1, y1, this is my x2, y2. That means that I'm doing -2 plus 4 divided by 2 and 3 plus -1 divided by 2 gives me a 2 divided by 2 and a 2 divided by 2, which ends up giving me a 1, 1. So now that I have this 1, 1, that means that the midpoint would be, starting at the origin, I will go right 1 and up 1, and this is my midpoint. I hope this video has been informative for you. Look for other videos to be on my website. Have a great day.